the 18th of June and second time now. It's 11:12 a.m. So I'm kind of wondering how this will work, but I've discovered that that compile time code I'm turned into a signal that's also electric. So you got electric computation over electric signal, and you got magnetic computation. So you got electrical magnetic model of composition. And the beauty of this is just you don't need a set on a different state machine just to convert one state machine to another. I'm speaking about non-charging hardware, but everything that goes through an electrical system has its magnetic machine equivalent. And to say the least, that means every signal that's electronic has a magnetic field, which gives you to EM wave, electromagnetic wave theory, or wave theory, which I like wave theory. Basically, wave theory, because every state machine you have, or state machine can be converted to electric and magnetic machine. That's magnetic tape. And the beauty of this, you write compile time code to understand what I mean. So if you compile something, you don't need to compile a machine learning model. For say, one application is like, you can try something that's electrical, that system has a magnetic counterpart. So, basically you use one for compile, one for random. And it's not an AI institution, it's an AI model. So basically, the beauty of this, I'm introducing my own model set of AI models. I believe the real breakthrough here is in the allowing my drone delivery system to be fully autonomous without any machine learning code and training. Because if you go a path, it'll fly through a path and be flying over the surface. So take an orange and cut the orange in half, and it will take the A star which goes to point A on the orange part, point B, via the curvature of the Earth, which is a parabola, which is the heuristic graph with G that's computed, G of H, where H is the heuristic path taken. The Easter algorithm is literally going to allow this to work, in a sense of way that is fastest path, shortest distance, but has a sense of direction, which is basically the drone path. Now, if I have some kind of flight component in a drone, I compile my drone model. Sorry, guys. I compile my drone model, and the magnetic. Basically, you're gonna have electric shape. You're gonna have magnetic. And the distinction I'm making is there are two types of state machines. They're all just two machines. I can't really formalize it, but I'm going to try and formalize it today. So this is basically based on Chomsky hierarchy. You can say they're the same system, just have one was the runtime, which is electroconnect. So you have to double compile. And we need to model a system that can fly and compute while it's flying at runtime. Can we compile? Or say, if it compiles, it compiles, it takes a instruction. So it's like some kind of instruction and comes into an executable and links it, then compiles it into a executable. By linking it, it has to load all the assets. And the Insidia protocol has to adopt this model too, because it's not an machine learning model, but it's basically a library kind of this is about what the library is built in. If it's electronic, it's an electric. And if you have a standard lib like a lib.a, it's a static electronic library, which has a lib.am magnetic library, because the two components are related. They're electrical spectrum. The beauty of design can use this model to conscious switch between the electrical runtime of the code and the magnetic compile time of the system. And this basically allows you to recompile the code in a way that that system electronic magnetically is intertwined, and you have something that's like the actual space understand the fabric of space time. Basically, understand the plane. It's not as small; it just sees more with less, because you have to train an actual model to do so. And the state machine is literally the component of it together. So if you have an EM wave, electric signal, there's a difference. If you have an analog waveform, let me see what I mean. So this here is this is two wave. So this basically an analog waveform inscribed inside a digital waveform, And as you can see, the digital waveform shows you the runtime equivalent of 1 and 0, and the analog equivalent can be the runtime of an electric system via listen, you get analog systems and you get digital. The digital waveform or digital waveform has amplitude modulation, but this is the square wave, the square wave. And the square wave is digital signals. And digital signals are square wave. You get a sine wave. Now the sine wave represents analog systems, but the same wave propagates because they're inscribed into each other. If you have a reflected step of those waves, if you reflect the waves, you can see they're all isomorphic. They all share the same, because they cover the same ground, but they refer the same information. And this one based off of, this one discovered because the waves are sine and cosine, but they have the same information just because they're inscribed into each other, and no matter how you reflect them, if they're not the same wavelength, they will not be feeling the same. But because because you want other 1 of 0, it's because the steps to take is the 1 of 0. The single step is the 1 of 0. Which is the first single step is step is a half of 1 of 0, which the first is using to distinguish between the two properties of electromagnetic model. I'm gonna not use it for AI for now. I'm gonna use it to build artifacts that electrical model. Because something that runs a runtime needs to load a magnetic system, like an insignificant magnetic system. And the magnetic model is so the memory is magnetic, and the system and it's the human rights protocol ensures electrical. So this was discovered. I'm so proud of myself. I know this will work because I've tried it before, and doesn't matter if the message is a state of supervision or not. There are two states in one system of electrical wave. Basically, Richard of York, rent money, radio waves, microwave, infrared, visible light, X-ray, gamma rays, is visible under X-ray. My goal is to make an insignificant file and I think go G for gold. I think okay. Take my goal. My first project. My next project will take. Well, basically, my project now is to. My next step is just make a magnetic library lib if I make a linker, make one linker, and link magnetic systems into a system as two one for runtime, one for compile time, and see how they interpolate via magnetic memory model. Because the memory is very powerful to see how this works. But if this works, it should be to output something executable that runs that respects the runtime of the state it is. So when it crashes, it can get up and go. Like a drone, when a drone crashes, it can get up and go. You go back to the base and live up some food, water, and shelter. Thank you for watching the video, Namdi.